Classic cars can have old car problems like wiring issues, like the headlights don't light, the wipers don't wipe, the blower fan doesn't fanulate, and the crank doesn't crank and start. These can actually be all very similar in the way that these problems occur. Let me show you how to find these issues so that way you can correct them. The good news is there's only two things that you need. You need a good set of wiring diagrams, and you need a voltmeter or a test light if you're a test light kind of guy. I lied, there's actually a third thing. Check the description of this video. There's a link to my electrical diagnostic troubleshooting checklist. So just some real quick electrical theory we all know. Everything starts and ends with the battery. Power's got to leave the battery, power's got to come back to the battery. Connections in between, if they're bad, corroded, broken, you're not going to be able to make that circuit work like it's supposed to. So to start off with, check the quality of your battery cables and the ground connections. If they're gross and having trouble, that's a good sign that there's a lot of systems that could be having trouble and could be cleared up just by taking care of those things. Step one, we need to know the voltage of the battery. 12 volts. That's the number that we're going to be shooting for when we're troubleshooting every other circuit. The second thing I recommend just to do real quick while you're here, verify that you have good continuity between the negative side of the battery, the engine, and the body. You can do that in the ohm mode. I'm going to touch here to the negative side. I'm going to get unstuck, come over here, and verify that I have good continuity between the ground and the engine. And then I'm going to come over and do the same and verify the grounds that are closest to the battery because they're convenient and easy to get to. Knowing those two things means that I've got good connection between the battery and ground. You hear people say, check the grounds! That's because most circuits actually have problems on the ground side. It's a connection that runs after the load to the ground or the body or the chassis or engine, wherever it may be. You got to make sure those are clean and conduct electricity nicely. Okay, that's great, but let's get on to the important stuff. From here, we need to verify fuses, connections, and grounds. So, the next step when you're verifying any electrical fault, check the fuse. That's an easy thing, and if there's a fuse broken, that could be a sign of another problem, or something just could have happened from old age, because, you know, these are old cars. Things happen. It's okay. Okay, the fuse is now known to be good. What's next? Well, grab your wiring diagram. This happens to be the factory service manual wiring diagram for my El Camino. However, being a G-body Buick Regal, the wiring colorations are pretty much the same, save for a couple of circuits the El Camino didn't have. But the point remains, grab yourself a Haynes or Chilton manual, get the wiring diagrams, and that way we can start to look at the coloration of the wires and where they go. So, after the fuse checks out good, the next thing I usually say is move to the next component. But if it involves taking things out of the dashboard, let's bypass that for now and just see if power is getting to the component. See what I mean? Headlights, G-car. G-body, also a G-body. So, we're looking at the this is the light switch as identified here. We have yellow coming out. This is the headlight dimmer, meaning the on the stock, the low beam, high beam one. So let's look for the low beams because that's the one we're going to use most. So out of the headlight dimmer, we have tan that moves to a connection. That connection goes to the left-hand low beam and the right-hand low beam, and believe it or not, there's actually a connector in here that's in the middle of the nose on G-bodies. So make sure that you're, if you're chasing a weird issue, check that. Sometimes that's an issue. But we're looking for power on the tan wire. Remember, we're looking for that 12.2 volts that we saw at the battery. So let's go check that. So when troubleshooting electrical stuff, we want to know that there's power when it's supposed to and no power when it's not supposed to. I have a good chassis ground or body ground right here that I've got my meter hooked up to. I've got in volts DC. Here's the tan wire. Let's just verify that there is no voltage when the switch is closed, or a switch is open, I should say. The circuit is open, the headlights are not on. No voltage. Now with the headlight switch on, let's verify voltage. I'm seeing 11.3 volts, which means that there's some corrosion somewhere that's impacting this. The other thing you could do is with the switch on, verify the voltage of the battery, because sometimes when you put a load on it, the voltage drops a little bit. That's just the way electrical stuff works. So I have power here at the connector, and I'm noticing that there's a fair bit of corrosion-y stuff. That corrosion it makes for a less friendly connection. In a perfect world, you would take this connector out, clean it up, or replace it as you need to, and that would make the circuit work better. So if you've got power here, but it's not good power and doesn't match what's at the battery, there's a good chance that this connection or the connection under the dashboard at the light switch is to blame. So what you would want to do is verify those connections. Now, I'm happy enough with 11.3 volts here. What's the next step? Oh, I know why there's a, look at this, my ground fell off. So the next thing that we're gonna need to do is to verify the ground of the circuit. So I'm gonna go to ohms, and per the wiring diagram, this black wire is the ground, so I'm hooked up to my ground here. Let's verify we got ground. You know, an ohm or so is perfectly acceptable on stuff like this. So I've got good ground and good power. So that means the component should work. Now, if that doesn't work, that means your component is likely at fault. You could have a burned out headlight or any of these things. And the headlight's probably the poor example, because if it was working and didn't, you'd probably just replace the headlight, right? But this is true across any circuit. If there's a problem that you're not getting power, you need to make sure that all the connections are good and everything else in line is good. Let's move on to a different circuit. Let's move on to a particularly troubling one. Your engine cranks, but it doesn't start. Well, one of the first things that I always do is verify that I've got power to the distributor or the coil where appropriate. That shows that you're getting power through the ignition switch out to the distributor. So let's check the power on this HEI. I'm going to do that just with a simple screwdriver. I'm going to undo the power connection and just check power there with the key off and key on, as well as you're going to need a helper to verify that you have power in the start position also. I'm sure somebody's going to ask, but that's a GM. Why the heck is a distributor in the front? Because this is a Buick. Buick put the distributor in the front in the mid-60s, and it kind of stayed that way. So the connection is right up here next to the radiator hose. That's the positive connection right there at the bat for the HEI. As a contrast, small block Chevrolet, distributor at the back. I've got it hidden by my air pen, but this is my race car, so it gets a pass on being able to get to it super easy. All right, in a previous test, we proved that the engine is grounded to the battery, so let's check voltage here. The key is off. I'm just looking for voltage to make sure this is functioning correctly. As soon as I can find my connection, where the heck did it go? There it is. So, key is off. No power, so that's a good sign. Let me go turn the key on. All right, key is on. You can hear the blower motor whirring away. Let's check power here. 11.3 volts, that's consistent with what we were seeing at the headlights, so we're in good shape. Now, I'm going to grab a helper, or you can grab a helper and verify that as you crank it in the start position, that you have power here. There have been more than once that an ignition switch has failed and it just doesn't have power in one or both of the positions it's supposed to. So verify both. And when you're done, make sure you put it back correctly so that way the connection is solid and you always know where it is. All right, let's talk for just a minute. If you, in the start or run position, if you don't have power here, then you know that the difficulty is that way of the component. So the things that are upstream in this case would be the ignition switch and the ignition fuse. So you're going to want to go, obviously, check the fuse first. And secondly, the ignition switch on the G-body cars with that tilt column is actually not at the key. You have to drop the column to get to the ignition switch. A little bit of a pain in the butt. But from there, you would check that, make sure you have power coming into the switch. And if you don't have power coming into the switch, then you probably have a problem with the fuse box, like I already mentioned, where the terminal may be corroded and have problems. I've got another video on that to solve that one. But from there, you would verify all the normal start and run positions, that you have power going into the switch, and that would come out of the switch. And if you don't have power coming out of the switch is to blame. Now, if you do have power coming out of the switch, you're going to need to verify that you have a good contact between the component and the switch. You can do that in ohms by turning to ohms and touching one end of the wire out here and the other end in there. If you have a short or an open circuit, then you know that wire's got problem. You can start chasing just that wire back to its source. So you can see how electrical really isn't that hard. It's a methodical approach of starting here and ending here. And granted, we checked at the beginning and we checked at the component, but if we know that stuff is not at the component but at the beginning, that there's something in the middle, check the fuse, check all the connections, and replace those connections as necessary. So I mentioned the wipers, and we would troubleshoot that exactly the same way. We'd verify that we have power at the fuse block. We check the fuse, make sure that's happy, make sure that the wiper motor itself is grounded, pull the connector, make sure that we have power in the places it's supposed to, in the intermittent, if so equipped, low and high, as well as make sure that any connections in the connector are grounded appropriately per the wiring diagram. Now, the wiper motors themselves, they do fail from time to time. It's an old electric motor, it happens. You can bench test these things with a couple of alligator clips and looking at the wiring diagram and making sure that you put power in the right place and ground in the right place. And if it takes off, then you've got a problem that could be potentially connection related or the switch upstream. Same thing. These are all little things that you check to get to the end result. So you can see that electrical troubleshooting really isn't that hard as long as you take a very step-by-step approach and go through it. When you find power at one end and not at the other, that means there's something in the middle that's broken. Now, intermittent electrical problems are the worst, but they pretty much always stem from a loose or corroded connection. Like if you've got a wiggly connection in the middle, and it's an intermittent fault, like a taillight as an example. That connector may be corroded, may not be pushed in correctly. There's a number of things. So when chasing those intermittent problems, you're going to want to make sure you run the length of the wire and verify that everything is as it should be. So it's really not that hard. So get yourself a good wiring diagram, get yourself a multimeter. It doesn't even have to be a fluke. Everyone loves the fluke, but they're more money than what it's worth for the hobbyist. A good one can get you by. And if you want to learn more about some more electrical troubleshooting stuff that I've got, take a look at this video over here. Thanks for watching, guys. We'll catch you later.